Hi boys and girls, this is Sally Morse. I'm a district math coach for Henrico County Public Schools. For today's lesson, we will be expanding on what we did yesterday when we started learning about classifying quadrilaterals. To recap, we noticed that some quadrilaterals have no pairs of parallel sides. Trapezoids have exactly one pair of parallel sides. And parallelograms have two pairs of parallel sides. We can further classify parallelograms as either squares, rhombi or rhombuses, or rectangles. Today we will be looking at the properties of all of these parallelograms. Our I can statement for today is, I can identify properties of parallelograms, rectangles, rhombi or rhombuses, and squares based on their sides and angles. Here I have two examples of parallelograms. We're going to start with this one. It's made of anglex, so I can shift the angles on here, but notice no matter how I shift them, the opposite sides remain parallel. These sides remain parallel. And the opposite sides remain congruent. This side is the same length as this side, and this side is the same length as this side. Parallelograms have two pairs of parallel sides, and opposite sides are both congruent and parallel. Opposite angles are also congruent or the same. So this angle is the same measure as this angle. Parallelograms can have four right angles. We can model right angles with a square inside of the angle. Rectangles are a special type of parallelogram with four right angles. Opposite sides are parallel, and opposite sides are congruent. Now I'm going to go back to my blue parallelogram. Again, notice it has two pairs of parallel sides, and no matter how I'm moving this, opposite sides stay the same length, meaning they're congruent, and they stay parallel. They would never touch. The opposite angles are always the same measure as well. When parallelograms have four congruent sides, we call this a rhombus. We can model congruent sides with hash marks. Rhombuses or rhombi are a special kind of parallelogram with four congruent sides. We can easily see that because they're the same color here. Opposite sides are parallel and congruent, and opposite angles are also congruent. Notice every time I shift like this, my opposite sides stay parallel, and my opposite sides are, actually all my sides are congruent. That's what makes this a rhombus. Parallelograms can have four right angles and four congruent sides. This shape is a square. Squares have four right angles and four congruent sides. Because a square has four right angles, it is also a rectangle. And because a square has four congruent sides, it's also a rhombus. A square can also be classified as a parallelogram because it has opposite sides that are parallel and congruent. I like to use this chart to help me think about the properties of parallelograms. When I go up on the chart, I can say is a. For example, a rectangle is a parallelogram, or a square is a rhombus. When I go up on the chart, I'm saying is a. But when I go down on the chart, I want to say could be. For instance, a quadrilateral could be a trapezoid, but it doesn't necessarily mean that it is. A parallelogram could be a rectangle, but again, it doesn't necessarily mean that it is. To review, we can classify quadrilaterals by their number of pairs of parallel sides. We can further classify parallelograms by their sides and their angles.